Hi and welcome to Statistics Video 1. In this video we're going to be reviewing some of the old data definitions that you will have covered in previous years. In this video you'll consider types of data and some of that common vocabulary. So we're going to start off with some pairs of definitions, starting with primary and secondary data. So primary data is data that comes straight from the source, and typically that means that you will be involved in some way in collecting it. So it might be as simple as asking some of your peers what their favourite TV show is, or maybe counting cars as they pass through an intersection, etc. Secondary data is data that hasn't been collected specifically by you, that you have taken from another collection source. So a really good example of secondary data is any time that you use data from the internet, it's secondary data. Now, the difference between primary and secondary data is that we can make the assumption our primary data is more likely to be a reliable source. It's something that we've collected. Whereas secondary data often is quite reliable, and in this day and age we can make sure it's more reliable, but there are times where we just collect data from someone who hasn't done a good job collecting it themselves, and we just don't know. So there's primary and secondary data. Second, we have a census and a sample. But first we need to know about a population. So a population is the entire set of data. Now, it's very easy to think of population in terms of countries, and you might think that the population is the number of people in the country. And depending on our context, that would be true. But a population can be any set, any group of people. It really depends on the context. So if you're trying to find something out about your school, and you want to know a student opinion, then the population will be all the students in your school, and you wouldn't bother going out and asking other people from outside of the school. If you're trying to find out things from your community, maybe for a local government official, well then your population will be your local community area. Sometimes your population might be split into male and female, or into different age categories, depending on what it is that you're trying to collect. But ultimately your population is everybody that is involved in that group, or everything, depending on the context. So in terms of population, a census is a collection of data that involves the entire population, not just part of the population. So if we take a census, we are asking or collecting data from everyone or everything. A sample, on the other hand, is when you collect data from just part of the population, not the whole lot. Now, I've written here some notes about why you would choose a census and why you would choose a sample. So first of all, a census typically will be more accurate and more reliable. We've got all of the data, and it will contain a complete range of possibilities as well, which is a really important point. If you're trying to collect data on what a group of people would like to eat, it's really important that you understand all of the options out there. So you might find that over 50% of people would prefer to have pizza for dinner that night, but somebody may come up with an option that you hadn't thought of. And if you take a sample, that option might not come out, and it might be an important option. Why would you choose a sample though? Well, a sample you might not be physically able to take a census. So in some cases, censuses are difficult to take, but also the population might be unknown. So an example I'll give you here is if you were planning an event, let's say, for example, a music festival, and you wanted to know which bands people would prefer to listen to. Well, the problem you have is your population is all the people that will attend the music festival, but you don't know who will attend the music festival. So instead you have to take a sample. And in that sample, you're going to try and get some data off people who might attend the music festival, the clients that you might be getting. And from that data, hopefully you will be inviting them to take part. But ultimately, you just don't know. You may also want to take a sample because you might care in particular more about specific subgroups, such as girls or maybe a particular age category. But probably most importantly, you might want to choose a sample because it costs less and it takes less time. And so that's your time and cost argument there. So there's census and sample. Then we have the big one, qualitative versus quantitative data. So first of all, qualitative data is sometimes known as categorical data. And it's named categorical data because it's about representing data in categories. There's data that can be collected and put into categories. So for example, eye color, favorite movie, maybe a local government survey might ask about people's preference for the use of an area of land, whatever it is. That as long as it fits into categories, then it can be deemed as categorical data. Now, quantitative data is also sometimes called numerical data. And so this is data that we collect that is numerical in nature. It's data that we could probably use to find some averages and make assertions about certain variables based on that data. Now, numerical data can be split into two types as well, and those two types are discrete and continuous. Discrete data is data that goes up in distinct steps. So you might have 3 of them or 4 of them, but you won't have 3.5. Continuous data, on the other hand, doesn't go up in distinct steps. Every number can be included in continuous data. Now, if you have a look at my definitions here, I've got actually some examples of qualitative data: eye color, hair color, type of house, breed of dog. Quantitative discrete data, the amount of pets you have, the amount of students in a class. And quantitative continuous data, speed you're traveling, the height of anything, time, for example. Now, I've got a couple of whatabouts, but first I just want to show you this definition here. This really does simplify it. Discrete data is countable. And it doesn't always have to go up in ones. So, there might be a situation where things go up by halves and it's still discrete data, but typically discrete data is countable. So you'll have 1 of them or 2 of them or 3 of them. Continuous data is measurable. So think about this. If your variable is in a unit that is measured, so time or distance of any sort, so kilometers or millimeters, and capacity or weight, all of those things that you measure are continuous data. Now, we have some common ones here that get asked about. What about something like age? Now, age is one of those ones where you'll typically state that you are 16 years old or you're 17 years old. You don't often declare that you're 16 years old, 4 months and 7 days. It just doesn't happen. But despite this, and despite the fact that we significantly round our ages, it's still a continuous variable. So it's still a time-based variable, which means that your age is based on the exact amount of time from the moment you were born. So it's really a continuous variable, dependent on the context and what's been stated. House number I've been asked about on occasion, and house number is a bit of a tricky one. So it's a numerical data, but it's not really the type of numerical data you would consider taking an average of or that you can use to compare. So if you live at number 25 and your friend lives at number 25, well, that doesn't draw any inference between the two of you. It says nothing at all that we can claim based on that, because your streets are different. And you might live at number 25 on a street with 1,000 houses. They might live at number 25 on a street with 30 houses. And so there's no real inferences, and because of that, it really is a categorical variable. And on top of that, you can get house numbers 25A and 25B and 25C. So really, you're being sorted into some sort of category there. And shoe size is another good one because it's kind of discrete, but it goes up in halves. So shoe size, it has that discrete feel about it because you have 9.5 or 10 or 10.5 or 11, but you don't have 10.2. So that means it's definitely not continuous. But I think the argument here again would go that this is a categorical data and the shoe sizes are categories. And they could just as easily have names, or they could be your shoe size A or B or C instead of having numbers. So those numbers are really grouping names, and therefore it's categorical data. So just last of all, let me just draw a quick diagram here to remind you that we have qualitative data, or we have quantitative data. So this is your categorical and this is your numerical, and the quantitative data can be split into discrete or continuous. And they're all the types of data that you're dealing with really up to this stage in your maths. All the best.